if you take a default mask, the number of hosts would be more or less. It can be greater than or less than, but it is not what is our requirement, right? You take any class, whether it is class A, B or class C. Class A, if you take default mask 255.0.0.0. If you take class B default mask 255.255.0.0, then class C if you take 255.255.255.0. See, whenever you are trying to figure out how many host entries we have in particular class or how many addresses we have, it will always be calculated based on a network your subnet mask only. See, when what we said previously, if it is all ones in a subnet mask, it is network. If it is all zeros, it would be host. In each 1 minute, hold on. Yeah. In each octet, how many ones are there? That would be network bits. How many zeros are there? That would be host bits. Okay. So in this, all are ones. This would be network. This would be host, host, host. Again in class B, this is network. This is network. This is host and host. You take class A, three bits are network bits. One bit is host bit, right? One octet is a host octet. So when we calculate, if we have all zeros, how many addresses are there? Let's say class A, it is 255.0.0.0. We have three host, right? Three host octets. So in each host octet, we have 256, 256, 256. If you multiply this, you get something like 16 million addresses, right? When you come to class B, you have less numbers compared to class A. Now in this we have two host addresses. If it is all zeros, it is host, right? That is our understanding, and that's how it works. So if with all zeros, it is host, host. Now it will come 256, 256. If you multiply both of this, you will get 65,536 addresses. These are host entries or number of addresses available in class B for each network. Then if you take class C, you have less number of addresses, but still in some cases we don't need all three. We don't see this is network, 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 but it is host. If it is only one host octet, it would be 256. But there are some requirements that we don't need 256 users in our network. We need less than 256. I need only 100 users in my network, right? There are departments usually in your company. Suppose you have two departments in your company. For simple example, one is IT department, one is a HR department, correct? In IT department you have 100 users, in HR department you have 100 users, right? And you don't want to use different subnet, different range of addresses. You want to use same range. Assume 192.168 0.0 range only you want to use, but you want to make sure IT network is different, HR network is different. Then you can divide this particular. See, as of now we have 8 host bits, right? If you take all the 8 host bits, it would be 256 addresses, but our requirement is only 100 addresses. So to get a 100 addresses, what is 2 power? For 100 addresses, 2 power 7 it is, right? If you take 2 power 7, how many host bits we need? We need only 7 host bits. So what I am going to do, as of now I have 8 host bits, but my requirement is 7 host bits. 8 minus 7. So what I am going to do, this one remaining host bit I am giving to network, right? Correct? Till this it is clear, right? Guys, I'm audible to
Yes.
everyone. Yeah.
Yes, yes, it is
Yeah.
clear.
So
Yeah,
once I give this one host bit into a network bit, the subnet will change. The default subnet was 255 255 255.0, but instead of 0, now it would be different, right? Because if all the 8 host bits are there, then it would be 0, but instead of 8 I have now 7 host bits, right? So let us see: 128, 64, 32, 16, 8, 4, 2, 1. Whenever we are saying I need only 7 host bits, let's see, I'll write all zeros here. 7 numbers over, right? 1 2 3 4 5 6 7. So here it would be 1. So this would be my network bit now. All are host bits now. So my the new subnet mask would be from here to, it will change to new subnet mask now. Oh yeah, 1 minute. The new subnet mask would be different now. What is the address we have now? 128, right? Because we have only one host bit we are converting into a network, so this is my new subnet mask. Now when we have, see, when we don't do any changes, we clearly know what is the first address, what is the last address, correct? The first address would be network address and the last address would be broadcast address. But when we are not doing any changes in the subnet mask, we can easily say, when we write 192.168.0, see, whenever you do this type of calculations, first take whatever the network you have. This is network, this is network, this is network, right? So we are taking as it is the 3 octets. This is network, network, network. Now we need to figure out what is our first address in our host bits. So in our host bit, 0 is the first address, right? There is no number less than 0. And what would be the last bit? See, if you calculate all of this, that would be the last addresses, right? 192, 168, 0.255. This would be our last address, correct? What is 2 power 8
Yes.
usually? 2 power 8 is how much it is? 256, right? 0 to 255, it would be 256 numbers, right? If you take 0 to 1, it is how many numbers? 2 numbers now. 0 to 10, 0 to 9, it is 10 numbers. If you take 0 to 10, it would be 11 numbers, right? Similar to that, 0 to 255, it is 256 numbers. And we had 8 host bits, that's why we got 256 addresses. But now, after we do changes, now our subnet mask change from 0 to 128 now. Now we need to figure out what would be our network address, what would be our broadcast address, and what would be our valid host. Valid host means our machines addresses, what addresses we can use for our machines. So let's see, I will say, see, simply what I am doing, let's take one box. This box we had 256 addresses, okay? I am dividing this 256 addresses into two parts now, because I am dividing into two parts. Why? 1 minute. 256 divided by 128, it is 2, right? So let's see, what is a PE value? This we call it a PE value now, okay? Place value. So I am dividing 256 into 128, I got two numbers. So 128 here it would be, 128 here it would be, correct? This is one, this is one network now, this is second network I have now. Based on my requirement, this is my IT network now, this is my HR network. Clear? Now for IT network, what would be network address? Let's see, 192.168.0. This is my network bit, network bit, network bit. 255, 255, 255.128. This is my host bit now. So if I take a 0, then the first address anyhow it would be 0, right? So I will write a network address. 192.168.0.0, but the broadcast address will change. Instead of 255, now the broadcast address would be 0 plus 127. 0 plus 127, it would be 128 numbers, right? 0 to 127, how much it would be?
128.
It would be 128 addresses, right? So 128, our actual requirement was only 128 numbers we need, 128 addresses we need. Requirement was 100, but we will get 128 as a 2 power 7, correct? So if you add 0 plus 127, it would become a broadcast address, 0.127. Okay, now what is a valid host? Let's figure out valid host now. 1 minute. So valid host is pretty simple. If you get network address and broadcast address, in between network and broadcast address, whatever addresses you have, 0.1 to 0.126, these are all valid addresses. This is our IT address. We can call it a IT address now. Suppose you have 10 users or 100 users in a IT department. All the users will get address from this particular range only. Suppose I am from IT, my computer IP would be 0.1, and another person 0.2, like that, 0.50, 0.100, but they will not get beyond 127. Okay, now we need to figure out second address. Now for HR IT, it is clear now. Let's see. First write a network as it is, 0, subnet mask 128. We already consumed 0 to 127. What would be the next number? Next number is 128, right? 128 plus 128, sorry, 128 plus 127, how much it would be? 128 plus
257.
127, it would be 255. See, I am just adding 128 plus 127. Okay, so whatever the number comes, 0.255 it would come, right? 128 plus 127, it would be 255. This is our network address, this is our broadcast address. Why it is network address? Because see, before this 127, this was different address. Now when we do subnetting, this was different address now, and after this it is a different address. Now we are dividing one particular address. It is similar to that, you have one room which can accommodate 256 members. 1 minute. Suppose you have one room has a capacity of 256 users or 256 members. Okay, but you don't want 256 members to be in one room. So what you are doing, you are creating a wall between this room, and you are dividing 256 members into 128 members or 128 members. Now this is different group and this is different group. Okay, you can say here different members or here different members are sitting now all together. Okay, if you don't divide these 256 users, all will be sitting in one room and everyone would be part of one group only. But when we convert a host bits into a network bits, we are dividing the address to different groups. Okay, now in HR department, what would be valid addresses? Anything from 129 to 254, these are valid addresses. Anyone can use these addresses from HR department. Okay, is it clear?
Yes, for me it is
Right.
okay.
Yes, yes.
Okay, Sagar. See, now you guys are saying clear. If I ask it this after 10 days, you should be able to answer. Okay, fine. Now let's do a couple of examples. So whenever we do this type of subnetting, there are two ways. One is FLSM one is VLSM. I'll say you both of this. Let's delete all this now. Now you should be able to figure out how to get a network address, how to get a broadcast address, how to get a subnet mask, valid host in a subnet. Okay, if I give you any number, you should be able to figure out what is network address, what is broadcast address, and what is valid host. Okay, as you said, it is clear for you. Now let's see next part. Whenever we do subnetting, see all these particular topics, it will come under a subnetting. These all will come under subnetting. Whenever we do subnetting for IPv4, there are two ways. One is FLSM and one is VLSM. Now what is FLSM, what is VLSM? Let's see. FLSM, we call it a fixed length subnet mask. VLSM, we call it variable length. Calculation wise, both are similar only. There is no such difference in a calculation or finding out addresses. But the thing is, the names they call it FLSM and VLSM. That's all. But from an industry standard point of view, everyone uses a VLSM based based on their requirement. They use whatever addresses they want. For see, now let's figure out what is FLSM first. As in our last example, suppose I have 256 addresses. Okay, now this 256 addresses, either I divide into two addresses or I divide into four addresses, I divide into six addresses. It is not possible. No, okay, six addresses it is possible, I guess. Let's see. If I divide into two addresses, it would be two numbers, right? Here it would be 128. Here it would be 128. I am dividing 258 256 address group into two addresses, 128 128. This is see, when we do FLSM, both should be equal addresses. Here the same number, here the same number. Or either I can do divide 256 into four parts. I can do it into four parts. Then what I will get? 64, 64, 64, 64. Right? Correct? 6 it is not possible. Let's see. 8 it is possible. 2 power 8 to this particular group we can either divide into 2, 4 or 8 we can divide. Now instead of 4, if I want this particular 256 addresses divide into 8 group, I can do that also. Okay, yeah, it is not looking good. 1 minute, hold on. How many addresses now we have? 1 2 3 4 5 6 7 8. Okay, this leave it. Now 256 group I am dividing into 32, 32, 32, 32, 32, 32, 32, 32. How much it is? 32 into 8, how much it would be? I guess 256, right? 256. So what I am trying to say, whenever you have any address, suppose I have one address 192 168 0.0 and the subnet mask is 255.255.255.0. Whenever I am using FLSM, either my requirement should be 128 users or 64 users or 32 users, like that. Because I cannot use it like one I will use 128 users, then second I will use 64 and all, that I cannot do. So we call it a FLSM, because one particular address we need to divide into equal parts. 256 addresses I want to divide into two parts, then I will get 128 128, or I will divide into four parts, then I will get 64 64. 128 already we had seen an example, right? Let's see, if I divide 256 into four parts, what would be the addresses now? First let me write 128 64 32 16 8 4 2 1. So suppose my requirement is 60 users now, so what I will get, 2 power 6. 2 power 6 means 64, right? 2 power 6 means 64. Now let me first write new subnet mask for this. Default we had 8 host bits, requirement is we need only 6 host bits, so remaining 2 host bits I am giving into network. So the new subnet mask would be 255 255 255. This two network bits, this is 1, this is 2, I will convert into a network. Now this is network, this is network, this is all 0 0 0 0 0 0. These are all host bits now, right? So 128 plus 64, what it would be, 192. Okay, this is 192. Now my new network, my new subnet mask. Now I need to figure out if I am dividing 256 into 64, what would be my network address, what would be my broadcast address, and what would be valid host for each subnet. Now I will have four subnets. Okay, four networks. So first we need to find out a PE value. Now PE is 64 we have, right? So first write down, first network address will always start with 192.168.0.0. 0 to you add 63, 64 is your PV value, right? You add 64, 0 to 64, sorry, 0 to 63, it would be 64, right? 192.168.0. 0 dot 63 would be your next broadcast address. Okay, 0 plus 63, how much it would be? 64 addresses, right? If you add 0 plus 64, it would be what? 64 then. So 64 would be your next address, not this particular address. This is your first address. Second address, here it is ending with 63, right? Second address will start with 64 always. 168 0.64 plus you add 63 numbers, how much it would be? 127. Am I right? 64 plus 63, 127. So this is your second network address, broadcast address. In between this, whatever comes 65 66 and all, valid host. Now third network, here it is ending with 127. Third network will start with 128. 0.128 plus 63. What you can do? 128 plus 63, 191, right? 192, 168, 0.191. So this is your broadcast address. Now fourth address, 192, 168, 0 dot. Here it is ending with 191, right? So here it will start with 192. Then broadcast address 192 plus 63. See why we are adding 63? Because our PE is 64 only. 191 plus 63. Sorry. It is 192 plus 63. 255. 255 would be my broadcast address. Is it clear? See, either you can do in this way or there is another method. If you don't want to get more confused, this is your PE value, right? place value. So whenever you have one place value, you write first one network address. First network address you write 192.168.0.0. We are hiding 0.0 because there is no number lesser than 0, right? This is your first network address. 0 plus 64 you add, this will be your second network address. Plus 64, it would be 128, third network address. Then plus 64, it would be 192, fourth network address. So here the second address is starting with 64, right? Before 64, whatever address comes, 63. This is your broadcast address or first address. 128 here it is, so 127 would be your broadcast address. Here 120, here 192, so 191 would be your broadcast address. Here 192 plus 63 you add it, or you add a 64 number, it would be 256. So before 256, whatever number comes, 255, this is your broadcast address. See, either you can add a 63 and make a broadcast address, or add a 64, you will get a next network address. Okay. So when you see all these particular addresses, everyone is having 64 addresses in their particular address, right? Why we got 64? Because we have divided one particular group into equal parts, dividing into same parts now, right? 64, 64, 64, 64. Correct? Is it clear? Guys, you are able to understand?
I am not understanding that why we are grouping it in a four only.
No, no. Why we are grouping, that is later part. But how you are grouping, you are, if you are understanding,
Yes, yes,
that
I
is
have got that.
clear for, that would be enough for now. Why we are grouping and all, that will come in the next chapters. But
Okay,
how
okay.
you are
I,
grouping, suppose if I give you one requirement,
Mhm.
I want to group one particular, suppose I give you one requirement now. Example, I give you one particular address 192.168 1.0. Do a use a FLSM and group this particular address into 8 parts. So you should be able to do this. If you understand this calculation, that is enough for now. Why we are grouping, will come to that later. Okay. See, as of now, we have grouped this particular address into 4 parts, right?
yes.
So next you need to do it into 8 parts. So this would be
Okay.
your homework. Take this
Okay.
take this note. This would be your homework. How you will do, I need to know it by tomorrow. Okay.
160. 203, 8.
Whereas VLSM and FLSM is same.
Calculation wise, it is same, but the methods used are a little bit different. I'll come to VLSM now. Once you understand how calculation works, now let's jump into a VLSM then. 1 minute, I'll delete all this.
One.
1 minute. I'll use a different. Okay. So now we have done like what is FLSM, right? So see, when you do FLSM, all the network addresses subnet mask would be same. Either it would be 255.255.255.128 or 192 or whatever it is, the subnet mask for all the four network addresses, it was same, right? Correct, because subnet mask defines how many addresses we need. If you want only two groups, the subnet mask would be 128. If you want four groups, subnet mask would be 192, like that, right? Now when we do VLSM, okay, VLSM can be, suppose we have one address now, 192.168.1.0. Okay, so now my requirement is, I want first I want 100 users, then I want 60 users, then I want 30 users, then I want 10 users. Okay, so this type of things, when we have VLSM, each address can have different subnet mask. Now let's see our 2 power table. Now we'll see this particular things for VLSM. Now for 100 users I will use from a 2 power table 2 power 7. For 60 users I'll use 2 power 6. Then for 30 users I will use 2 power 5. Okay, sorry. Then for 10 users I will use 2 power 4. How many it is? Here I will get, if I use 2 power 7, 128 users I'll get. 2 power 6 I'll get 64 users. 2 power 5 I'll get 32 users. 2 power 4 I'll get 16 users. How much it is now? 128 plus 64 plus 32 plus 16. Sorry. 128 plus 64 plus 32 plus 16. It is 240 users. See, I have a group of 256 users, but from this I am using only 240 users for all my requirement. These are my four departments. For all this I am using only 240 users. So this type of things we will do with VLSM, where each of the network will have different subnet mask. So now let's do first over 192.168 for 100 users. For 100 users, what would be subnet mask and network address? Let's see. First let me write down. We need to figure out a PE value, right? 64, 32, 16, 8, 4, 2, 1. Now for 100 users, what is my requirement? I have 8 host bits now, right? But how many host bits I need? I need 7 host bits. 8 minus 7, I need to convert one host bit into a network bit. Correct? So if I convert one host bit into a network bit, what would be my new subnet mask? 255 dot 255 dot 255 dot 128, right? So this would be my subnet mask. Okay, now let's figure out second. For second I want 64 users only, so I will take two host bits, right? 8 minus 6, two host bits. So 128 plus 64, 255 dot 255 dot 255 dot 192. So for 60 users I will get the subnet mask of 192. Now for 32 users my subnet mask will again change. 32 users I need 2 power 5, so I need 5 host bits only, right? How many host bits I have? 1 2 3 4 5 host bits I have. So my new subnet mask for 32 users, 128 plus 64 plus 32, how much it would be? 224, I guess. It should be 224. 128 plus 64 plus 32, 224. So 224 is my new subnet mask. Now let me write it down here. For 32 users, 255 dot 255 dot 255 dot 224. Now for 16 users, I need only 4 host bits. Remaining 4 host bits I am giving into a network. See, these all will be network bits. These all would be a host bits remaining. So if I add 128, 64, 32, 16, how much I will get? 255, 255, 255 dot 240. 24 plus 16, it would be 240. So if you see in VLSM, all the network bits, all the subnet masks are different now, right? We call it because variable length subnet mask. Each requirement is different, so we are doing it different ways. Subnet mask calculation. Okay, the way is similar. See how we calculate for 60 users, 30 users. We already know, right? We are applying it in a VLSM method only now. Now let's figure out what would be the network address, what would be the broadcast address for each, for 100 users now. Okay, so now the first bit would be network bit. Let me write down this subnet mask 128. Okay, 128 is my network mask, subnet mask, right? So this is all network, this is all network, this is all network, this is one bit is network, all host bits, right? This is one network bit. Let me write down my address 192.168. See, whenever there is a network, you need to write down as it is t8 1 dot. Now here there is a mix of network and address. So how many 128 we need? And we are starting with 1.0. So the first number would be always network address. Okay, now we need to find out in the same what is the broadcast address for this particular address. 0 plus 127, it would be 128, right? 0 plus 127, it would be 127. The numbers are 128. So 192.168 1.127 is my broadcast address. Now 1.1 or 1.2 or 1.126, these are my valid host for 100 users. See, for 100 I will get 128 addresses. 0 to 127, it is 128 addresses. Now for 64 users, let me write down network subnet mask for 64 users. What was the subnet mask for 64 users? 192, right? 192. What was my last address I used for 100 users? 192.168. 1.127 I used, so I will use the next available address, which is 128 now. So after 128, if I add 128 to 64, 128 plus 64, this would be my next address. So before this 60 next address, whatever number I get, or I can use 128 plus 63 also. 128 plus 63 I will use, I will get 191, or 128 plus 64 I will use, sorry, 128 plus 64 if I use, I will guess 192. The next address would be starting from 192. Here the last octet I am saying. Okay, so before this I will get 191, right? This is my broadcast address for this particular subnet. Okay, now I will use for 32 users. So after 192, what is my next address? I got 190, 191, I got 192. Let me write down a subnet mask 255 dot 255 dot 255 dot 224. Correct? So 224, that means 192, 168, 1 dot. After 192, I will get 191, I got a 192. 192 plus 32. This would be my next address. See, whatever is our PE value, our PE value for 30 users was 32, right? That's why I am adding a number 32. I am not saying our requirement is 60, you add 192 plus 60. It will not work like this. Whatever is your PE value, you need to add that number to get your next address. Okay, you're getting my point?
Yes, yes,
Yeah.
I got it.
So 192 plus 32, how much it would be? 224 it would be usually,
24.
right? So our broadcast address would be 223, and in between this 193 to 222, these are our valid host. Now our requirement was 10 users, but we got a PE value of 16. This is our PE value. So let's see, for 16 users, 168 1.224 plus 16, how much it would be? 240 would be my next address, not included in this. This is my next address. So before this we get 239, right? 1.239 would be my broadcast address, or else you can do 224 plus 15 also. That will also work for you. 224 plus 15, 239, right? 239. Yeah. Hold on. So now let me write one more table for you to understand how FLSM worked and how VLSM works. Now suppose we have one table. If you take FLSM and we take VLSM, sorry, this was FLSM, this is VLSM, this was our requirement. Okay, in FLSM your requirement cannot be changed. Okay, see, if you take FLSM one address, our address is this, assume. In FLSM you need to divide it into equal parts. You divide it into four groups, or 8 groups, or whatever you want to divide, it's up to you. Okay, but in VLSM, same address you can use it for 5 or 6, and still you will have some valid addresses available. Okay, or 6, whatever we want. Now let's see, if we divide 192.168, 192.168.1.0, I divide into FLSM and VLSM, what I will get. Okay,
192.168.1.128 for FSM.
I am dividing into 4 groups now, assume. But my
Okay.
requirement is this, I have a requirement of 100 users, I have requirement of 60 users, I have requirement of 30 users, I have requirement of 10 users. Okay, this is my requirement. But if I use FLSM method, what I will get? I will get all same only, right? I cannot do 100 users, or I cannot do 60 users. Either I can do 128 users, or else let's divide in this way: 60 60 30 30. I'll divide into 4 groups: 192 168 1.02 1.63. This is first address. Okay, in VLSM it would be same, the first address would be same: 1.02 192 168 1.63. Because our requirement of 60, we got 64 users. Now divide group 2: 192 168 1.63 was last address, right? I will use 64 to 1 minute. What I will get?
That
192
amount
168
that
1
will
dot
be 7.
64 plus 63, 127, right?
197.
Yeah. What about VLSM? 192, 168. Again, the requirement is same, so we will get the same address. 1 dot 64 to 192 dot 168 dot 1 dot 127. Now let's see the changes from group 3. Group 3, the requirement is 30, but in FLSM we started dividing with 64 users, right? Now we cannot change to 30 users in FLSM. We need to use same 192.168.1.128 to 192.168.1.191. 128 plus 63, it would be 191, right? Now in VLSM we can do changes. We can use it for 30 users also. So now let's see 192.168.1.128 to 192.168.1.128 plus 32, how much it would be? 128 plus 32, 160. So 159 would be my last address. Okay, is it clear? Now let's see group 4.
So the addresses can be saved in VS.
VLSM addresses can be saved. We can save addresses in VLSM, but FLSM we cannot save addresses. Okay, if you use FLSM, all the groups should have same addresses. Okay, now let's see in group 4 our requirement is 10 users, still we will get 64
Yes,
users.
VLSM 159 how?
Sorry,
128 to.
128 plus 32, requirement is 30 users, right?
Okay.
Yeah, and the last address we had was 128.
Last one 159.
Sorry, no, in
Last one.
VLSM we already used till 127, so after 127 the number would be 128, right?
128.
128 plus 32, it would be 160. So 160 is the next address. Okay,
Okay, okay.
yeah,
Okay, we are taking broadcast address. Okay.
yeah. 192 168 1 dot 192 is our first address. 192 168 1 dot 255 it would be. Now in VLSM again we can do changes. 192 168 1 dot 160 would be our first address. Then our requirement is only 10, but we are getting 16 because 10 we cannot get exact, right? If you see, for requirement of 10 we will get 16 addresses. So add 160 plus 16, 192 168 1 dot 175 would be our broadcast address. 176 would be next address, correct? 160 plus 16, 176 would be our next address. So if you see, if you use FLSM, you are not wasting many addresses. But you use VLSM, sorry, you use FLSM, you are wasting so many addresses. Your requirement is 30, but what you will get? You will get 64 addresses only, because you used a group of 64. Your requirement of 10, but you are getting 64 addresses. But in VLSM, when our requirement is 30, we can use either 32 addresses, and the requirement of 10, we can use 16 addresses. So we are not wasting. Here we are wasting only 4 addresses, right? But in this we are wasting like 30 addresses and 50 addresses, correct? And usually everyone uses FLSM. The calculation wise everything is similar. What is your PE value, that would be based on that only the calculation will happen. Okay, and in FLSM for any address you divide it into 64 group, the subnet mask, let's see subnet mask. In FLSM the subnet mask would be default 192. because our PE was, we need two network host, right? But in VLSM, for each address there would be different subnet mask. Here the subnet mask would be 255.255.255.192. Then second bit, it would be 255.255.255.192 again, because we are using 64 addresses here. Then third, the subnet mask will change to 24. Okay. And then fourth, again it will change to 255.255.255.240. Okay. If you see, in VLSM all the subnet masks are changing, but in FLSM the subnet mask would be default subnet mask if you divide it into a default group. Okay, group of 4 will have default subnet mask for all the addresses. Group of 2, if you do this with group of 2, then 128 would be the subnet mask last address. Okay, that's clear.
Yes.
Okay, now let's see, I gave you one homework, right?
Yes.
Yeah, now we need to see more.
I want to take a peek of that.
Yeah, yeah, please take it.
It's done. Thank you.
Everyone took a photo.
Yes.
Okay, 1 minute, hold on. One minute here. Shit.